Electricity has an important place in our lives. Most of the equipment we use on a daily basis are powered by electricity. It is a convenient form of energy compared to steam and other forms we had been using earlier. Movement of a fluid is called current. Like how we have water current and air current, the flow of electrons is called electric current. The path for the flow of electrons is called electric circuit. Electrons need a closed path to flow. If the circuit is broken anywhere, then there is no current flow. Electric current is measured by the amount of electric charges crossing a point in an electric circuit in unit time. It is the rate of flow of charges. Electric charges can be either electrons or ions. Electric current is measured in ampere. When electricity was discovered, electrons were unknown. Scientists thought that electric current flows from positive to the negative terminal. It is called conventional current. After the discovery of electrons, it was found that the electrons actually flow from the negative to the positive terminal. It is called electron current. We should follow the conventional theory and mark the flow of electric current likewise. Electric current is measured in ampere, which is equal to the flow of 1 coulomb of electric charge in 1 second. The smaller units of electric current are milli and microamperes. 1000 milliampere is equal to 1 ampere and 1000 microampere is equal to 1 milliampere. The instrument used to measure electric current is called an ammeter. It should be always connected in series with the circuit so that the actual current flows through the ammeter. The ammeter should not disturb the electric circuit. So, the internal resistance of the ammeter should be ideally 0 ohms. We need a few basic electrical components in an electric circuit like the battery or the power source, electric wire, the bulb, motor or any other load and a switch. What is an electric circuit? It is the complete, closed path for the flow of electrons. Define the unit of current. Electric current? It is measured in ampere. 1 ampere is equal to the flow of 1 coulomb of electric charges per second. There is a difference in the flow of charges in solids, liquids and gases. In solids the actual flow of the electrons is very low. It is only of the order of about 1 millimeter per second. Then how does an electric bulb light immediately once the switch is on? Imagine that there are 100 people standing in a line. Each person has a ball in one hand. The first person passes the ball to the second person. As soon as the second person receives the ball, he keeps that ball himself and passes the ball he has in the other hand to the third person. It happens continuously so the last person receives the ball. Like this, atoms in a conductor pass the electrons from one atom to the other atom. The last atom ejects the electron almost immediately when the first atom receives the electron. So, we get the feeling that the light bulb glows immediately without any delay. When there is the presence of either positive or negative charges at a point, we have an electric potential. If both the positive and negative charges are present, then a potential difference is created. The potential difference is also called electromotive force or voltage. Electromotive force is the force responsible for the movement of electric charges in a circuit. Potential difference means the difference between the positive and negative charges present in an electric circuit. Water flows from a place of higher to lower height. Likewise, electric current also flows from the point of higher potential to lower potential. Potential difference is defined as the amount of work done to move one unit of electric charge from one point to another point. Voltage is measured by the unit volt. 1 volt is defined as the potential difference between 2 points when 1 joule of work is done to move 1 coulomb of electric charge from one point to another point. The potential difference, voltage or the electromotive force, is measured by an instrument called voltmeter. The voltmeter should always be connected in parallel across the 2 points between which we want to measure the voltage. The internal resistance of a voltmeter should be ideally infinity so that it does not affect the circuit to which it is connected. A basic electrical circuit has the following components: a cell or a battery, a fuse or a circuit breaker, conductor and a load. A basic electrical circuit is represented by a schematic diagram which has simple representations of the electrical components. The flow of water from a tank depends on the height of the tank. If a dam height is more, then the water pressure and the flow are more. Likewise, in an electrical circuit the current flow depends on the electromotive force or the voltage.